In this video, we're going to discuss example 21. The integrand is made up of a product of an cosinus function and a sinus function, where each of these functions has a different argument. The integrations of the product of two trigonometric functions is in general more complicated than the integrations of integrand which involve individual cos or sine function. Therefore, when you have this kind of integration which is comprised of the product of two trigonometric functions, convert it into two separated functions that involve only cos or sine separately. This would make the integration much easier. You would like to convert the product of two functions into the difference or the sum of two functions that could be integrated independently. So let's see how we perform these integrations. So the trick here is to convert this into the integrations that involve two independent integrations that involve only sine or cos functions. The conversion from the product of two trigonometric functions into two sine or cos functions could be obtained through the identity of sine mx cos nx equals to half of sine m minus nx plus sine of m plus nx, where m and n are two integers. So here, you could easily identify 3x to be mx, nx to be 5x. So by using this identity, sine 3x cos 5x is then easily identified to be sine of m minus n. Here m is 3, n is 5. And write the m and n number here. M minus n will be minus 2. M plus n will be then 8. Simplify sine minus 2x further by using the understanding that sine minus 2x is equals to minus sine 2x. This relationship, that is from sine minus 2x equals to minus sine 2x, is by referring to the mnemonic CAST, namely for the angle in the fourth quarter, which is denoting a values of theta that is negative. In this sector, which is the fourth sector, only the cos theta is equals to the cos of negative theta. Whereas for tangent and sine with an angle in the fourth quarter, sine theta or tangent theta would be negative. I'll rub off this mnemonic so that I can make space to write down sine x here. So that would be the identity of sine 3x cos 5x. I can then write down the integrations to be the sum of minus 1/2 sine 2x dx plus half of sine 8x dx. You can now see that the integration for the product of two trigonometric functions now been splitted into the integrations of two integrations which involve a single trigonometric function only. The integration of an integrations involving only a single trigonometric functions is of course easy. This would be just minus half times the integrations of sine 2x is simply cos 2x divided by half with a minus sign. The integration for sine 8x term is simply cos 8x divided by 8 with also a minus sign. And don't forget the arbitrary constants. So simplify this would give you 1 over 4 cos 2x minus 1 over 16 cos 8x plus an arbitrary constant. So as a conclusion, we have successfully shown you in example 21 how to integrate the product of two trigonometric functions with two different arguments. This is done by decomposing the product of the two trigonometric functions into the sum of two sinus functions using the identity as shown here. That's why now you can see the importance of knowing the identity of these trigonometric functions. Once you are able to decompose the product of two sinusoidal functions into the sum of two different sinusoidal functions, then the integrations could be carried out straightforwardly to give you the final answer for this integration.